To make sure that there is one P in the 3 letters, there will be 2 possible cases that we are going to be considering. The first case, let me call it case 1. For the first case is if there were to be exactly one P. So it is going to be one P and 2 other distinct letters. And for these 2 other letters, they are going to be obtained from either H, A, or Y. So out of 1, 2, 3, I will choose 2 letters. And for these 2 letters mixed with P, we are going to be permutating them. So it is going to be multiplied by 3 factorial. And this is equal to 18. And the second case, I guess you guys can already imagine what is that second case. And that will be the case where there are 2 P's. 2 P's and 1 more letter. And for this one other letter, it is going to be taken from either H, A, or Y. So out of 3, we are going to be choosing 1 and mixing this 1 letter with the 2 P's, permutating them, it is going to be 3 factorial. And since the 2 P's are identical, so I will divide this by 2 factorial. And this is equal to 9. So the total number of ways that we are looking at here in this part is going to be equal to 18 plus 9. My final answer here is equal to 27. One particular male teacher insists on standing in the middle. So let this male teacher be here, which means that on the left, there will be 4 possible slots. And on the right, there will also be 4 possible slots. So after this male teacher has stood in the middle, I will be having 8 possible slots. So the number of ways, it is going to be just 8 factorial for this part. My answer is 4, 0, 3, 2, 0. For part 2, we need to have a bit of imagination since the teachers are going to be arranged from the shortest to the tallest and there are no 2 teachers that are standing next to each other. That means the way that they're going to be arranged is fixed. So there are 5 teachers and there are 5 female teachers and there are 4 male teachers. And at the same time, since the female teachers cannot be standing next to each other, the only way for me to arrange them will be female, the first one, the shortest one. Then after that, it's going to be a male teacher. Then after that, the next female teacher, which is taller than this. There's only one other person who is taller than this, but shorter than the next one, which is F3. And we have a F4, and we have a final F5. And since there are only 4 male teachers, so the male teachers has to be arranged this way in order for the female teachers not to be standing side by side. So the female teachers' positions are fixed, only the male teachers can be permutating, and there are 4 possible positions for the male teachers to be permutating. That is why for part 2, my answer is just simply going to be a 4 factorial. So this is equal to 24. Part 3 is very simple. We just want to make sure that the male teachers are grouped together and the female teachers are grouped together. So there are 4 male teachers, M, M, M. I'm going to group them together. And female teachers, F, 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 F. I'm going to group them together. So we have 2 objects permutating. So it is going to be a 2 factorial. Within this object, 4 of the objects are permutating. So it's going to be 4 factorial. Within this, 5 objects are permutating, 5 factorial. So this is going to give us our final answer for this part, which is 5760.